A gardener is going to dig up a rectangle of 60 square feet to create a new garden space. Now, with that information, we're going to do three different things. First, we're going to give three examples of rectangular gardens that have an area of 60 square feet, and we're going to state the width and length of each garden. Then we're going to find the perimeter of each of the gardens that we described. And then finally, if we scroll down here a little bit, we'll see the last question is asks us which garden from part A would require the least amount of fencing to enclose it, and how much fencing would it need? So let's take a look at this first part where we want to give three examples of rectangular gardens that have an area of 60 square feet. So as we think about this, we want to be sure that we're paying attention to all the information that's given. So we're interested in an area of 60 square feet. And remember, these are rectangular gardens. If they were triangles, we would have to think about it a little differently. So we know for a rectangle to find the area, that area equals the length times the width. And so let's come down here and just make a couple of different rectangles for us. Let's make one kind of long and skinny. And let's make one, I'll do some color coding here to help us keep track. Maybe a little bit fatter, kind of more this way, kind of a rectangle. And then our last rectangle, I'll maybe do something like this. And for each of these, we need them to have an area of 60 square feet. So we need to decide on a length and a width for each one of these that when we multiply them, will give us an area that's 60 square feet. So if we think about the factors of 60, that's what we're thinking about. What are things that multiply together to give us 60? That's that idea of factors. So there's lots of different things that multiply to give me 60. We could have 1 times 60. We could have 2 times 30. We could have 3 times 20. We could have 4 times 15. The list kind of goes on, doesn't it? We could have 5 times 12. We could have 6 times 10. And I think that that's about all of the different combinations that are going to give us 60. So for all of these gardens here, we can sort of choose just some different samples of these different ones. And so for this first one, because we can see if we call this side here the width and this side here the length, this one has a pretty small width and a pretty long length. So let's say that this one has a width of, oh, I don't know, let's say 2 feet. And this one, so notice that I'm looking at this combination here. 2 times 30 gives us 60. So if the width is 2 feet, the length would have to be 30 feet. Okay. Now the next one over here, this green one, looks like it's a little bit more stocky. So let's say that this one is maybe using this 6 times 10 combination. So this one would have a width of 6 feet and a length of 10 feet. Now all of these have an area of 60 square feet. Then for the blue one, we need one more combination. And again, we can choose any of the ones we want, but I'm liking this 5 times 12. So since this side seems to be a little bit shorter, we'll say down here, we'll keep it consistent and always have our length down here at the bottom. So that length we would say is 5 feet, and the width we would say is 12 feet. Okay? And each one of these, notice that when we look at the area multiplying the length times the length times width is 5 times 12, which equals 60. This green one over here, length times width is 10 times 6, which also gives us 60. And I just realized on this last one over here, the blue one, I wrote down 6 instead of 60. So let's fill that in. And then over here, the red one, length times width equals 2 times, oops, length, we did length first. So let's be consistent with that. Just erase that out. So if we're saying the length, we're calling the length here 30 times 2 also gives us 60. So all of those give us the area that we're looking for of 60 square feet. Okay. So we've satisfied this first part. Now the second part asks us to find the perimeter of each of the gardens that we described. So all of these are rectangle. I'm just going to scroll down here. And remember that to find the perimeter of a rectangle, we need to take two lengths, and to that we're going to add two widths. So we're going to use this perimeter formula to determine the perimeter of each one of the rectangles that we just found here. So for our red triangle right up here, we're going to say that the perimeter is 2 times the length. Well, the length we said was 30, plus 2 times the width. And remember this one, we said the width was just kind of that short little 2 feet stretch. So the perimeter equals 60 plus 4. So the perimeter for this one would be 64. And because we're talking about a perimeter, we need to have some units with that. 64 what? Well, all of these measurements are in feet. And since the perimeter is the distance around the rectangle, we would say the perimeter for that red one is 64 feet. Now let's do our green one over here. We're going to use the same formula of 2 times the length plus 2 times the width. So for this one, perimeter is 2 times the length, which is 10, plus 2 times the width. Whoops, I don't want to say width there. I want to actually put in my value for the width. And we said that the width on that one was 6 feet. So the perimeter for that one is going to be 20 plus 12. And notice the perimeter is quite a bit smaller on this one. The perimeter for this one is only 32 feet. And that seems a little bit curious that the areas are exactly the same, but the perimeters are different. Let's take a look at this last one and see. And I don't know, maybe at this point you could say, well, does it seem like the perimeter would be more than 32 or would it be less than 32 when we look at this last one? So let's see what we got here. Perimeter for this last one, 2 times the length. For this one, we said the length was 5 feet, plus 2 times the width. And on this one, we said the width was 12 feet. And when we simplify that right side, 2 times 5 is 10, plus 2 times 12 is 24. So for this one, perimeter is just slightly more than that green one that we did. This one's 34 feet. So now we found the perimeter for each one of our rectangles. Again, the area for all three of those rectangles was exactly the same, but the perimeter was different for all of them. And so if my goal is to use the least amount of fencing, which garden would give me that? Well, when the fencing would go around, so the fencing would be the perimeter. And we can see here that this one has the smallest perimeter, so that one would use the least amount of fencing. And so because they're asking us kind of a clear question here, we want to be sure that we answer it clearly. So I'm just going to type in my answer down here. Oop, just extend my page. So which garden from part A would need the least amount of fencing? Let's just scroll up to make sure that we've got the right information here. We want the one that had a length of 10 feet and a width of 6 feet. So the garden with a length of 10 feet and a width of 6 feet would need the least amount of fencing. It wouldn't, oops, let's go back and use proper English here. It would need how many feet of fencing? Remember that was the perimeter. It would need 32 feet of fencing. And so that's how we would finally answer the last part of that question. So lots of parts to that one. Oops, sorry about that. So lots of parts to that question, but we managed to cover all of the pieces, just taking it one piece at a time.